So what does it mean to be waterproof? It means that water can't penetrate. Water doesn't penetrate. Water doesn't pass beyond a barrier into the next space. What is a great measure of waterproofness? How about this plastic bag? What makes a plastic bag waterproof? Let me show you. As you can see, this bag is waterproof. Nothing comes through it. Now the real question is, how do we change that? How do we make the plastic bag breathable? We don't make the plastic bag breathable without the water going through it. We have to do other things. So with AIRADIGM, most of the things you're going to see are composite fabrics. You're going to see a composite fabric. And why do we make a composite fabric? Because there are two key elements to what makes AIRADIGM special. The first one we've discussed already, and that is basically what's been our core competency, which is making those expanded PTFE membranes, which are unlaminated and on their own rather mundane. It's nothing more or looks nothing more than like a clean sheet of material. It sticks to you, it moves around. Depending on the membrane that we're making, we define how permeable it is, we define how much water can go through, we define the porosity, and when I say porosity, we design how wide or how large the openings are within this particular membrane. This membrane, in turn, is laminated to a lining membrane or lining material, excuse me. That membrane is laminated to a lining material, and then what everybody thinks is the magic, which is actually, see, the PTFE sticks to everything, which is why we need to add it to a face fabric. The face fabric is the part that everybody sees. Face fabric is what it looks like on the outside, how it reacts to the outdoor weather, and that is kind of what makes a composite membrane. So the first element, as I mentioned, the PTFE membrane, and then the second element is what we've developed here alongside the PTFE membrane, and that is our pulse plasma vapor deposition process, where we're able to coat not just the face fabric, but we also coat the PTFE membrane on the inside, or if we need to, we can coat just the trico. And when I say that, we can coat just the trico, a great example of that is untreated trico. You can see me through this material. That's very breathable. I could stretch it over my head. I can make it as a curtain. It works for everything. It's very breathable, moisture wicking, that type of thing. You will find, before I make a big mess on the computer, you will notice on this material, water will flow directly through it, creating a bit of a mess. So in our process of plasma deposition, what we're able to do is stop that from happening. We can actually coat each one of the individual fibers and make the water stay on the top. If you've been following TTG or AIRADIGM on YouTube, you'll see a great video where this is illustrated, where if we take a tissue that you see here, I'm using the wrong color, but you'll notice how a tissue soaks up and grabs the water. We can take that same pulse plasma vapor technology and make essentially a tissue like this not want to go into the water. I can stick it in the water. You'll see that it comes out just as dry as it went in. That's the magic or science behind what makes AIRADIGM so special. So it's the combination of the ePTFE membrane and the pulse plasma process that really gives AIRADIGM its paradigm shift. It's the pulse plasma, it's the ePTFE membrane that forms our initial barrier And then it's the pulse plasma process that prevents any of the moisture from penetrating. And when I say penetrating, that's penetrating through the face fabric, the gray material that we looked at here a moment ago, through the membrane that we talked about, and through the tricho, keeping you dry and dry and dry, keeping your eye climate your eye climate.